Okay, people is coming. So we are going to continue with the talks in this afternoon. This is we start with one of the talks that I really like very much because I think Tokemak is an amazing project. I think the people in Tokemak, Manuel is one of the people who I learn more from him, talking about tokenomics, talking about a lot of things. He is a project that was very centric in the DeFi 2.0. They really defines a lot of things. So it's always I always say thank you to Manuel to be with us. And I think this kind of project is the second generation of DeFi, and that's why they are probably in the last mile of innovation right now. So happy to know more about what right now you are doing, and thank you always for coming.
Hello everyone. Hello everyone. Thank you for coming today. I think that this is... Can you hear me perfectly, right? So thank you for coming today. My name is Manuel. I'm part of the Tokemak team. And I'm here today to talk about the work that we've been developing throughout the past year, which is focused on LP aggregation for liquidity provision, or in other words, a new way to LP in DeFi. Okay, so agenda for today. I'm going to start by addressing the problem statement. So what issues are we trying to solve for both LPs and DAOs? Then I'll introduce Tokemak V2, which is our new system, and it's currently undergoing audits, and it's comprised by two different products. So Autopilot, which is a LP-facing product, and the Liquidity Marketplace, which is a DAO-facing product. Finally, I'll address Autopilot design, so a very high-level system overview, where I'll cover its architecture and core features. Okay, so LP limitations. What issues are we trying to solve for LPs in DeFi? LPing in DeFi is now far from trivial. If you want to provide liquidity to a correlated asset class, like for example, ETH-LST pools or stablecoin pools, you have a very large option set. And this very large option set in terms of different pools, DEXs, the underlying AMM models that we spend a lot of time analyzing, and different pool structures makes it very complex to optimally allocate liquidity for individual LPs. In addition to that, the APRs across these option sets are constantly varying. So if you as an individual LP are not capturing this delta, you're underperforming the market. And finally, there are high switching costs. Each time that you enter a pool, you need to pay costs in the form of gas, slippage, and trading fees. So ultimately, how can you create a dynamic allocation for liquidity that allows you to essentially outperform individual pools included in an option set while abstracting all the underlying complexity? So this is really the opportunity for LP aggregation. At the start, we're going to be focused on ETH. So any ETH depositor can deposit ETH on Autopilot, and we're going to dynamically allocate liquidity across a set of pools and DEXs. And in this chart, what you can see, it's just 7 different ETH-LST pools. And on the left-hand side, which is really in the early days of ETH staking derivatives, you can see that it's trivial to allocate liquidity. However, as the option set grows more complex and the volatility in APRs increases, you need a dynamic solution, otherwise you're underperforming the market, or you're leading to NAV decay because you're switching liquidity without actually recouping your rebalance costs. So if this is the issue for LPs that we're trying to tackle, so basically introducing dynamic LPing to outperform individual pools, abstracting the underlying complexity of all the different AMM models, and mitigating switching costs across different pools and DEXs, then we're also tackling the other side, which is more focused on DAOs. So the status quo for DAO liquidity rental, it's still based on gauge mechanisms. And the way that this works is that you need to wait for a new voting round. It can take, for example, 2 weeks. Once the voting round is enacted and the new gauge weights are enacted, you have an APR that is directed at the given pool, but you need to wait for a third-party LP to move towards this pool. The main limitation with this is that you do not know at which point is demand going to saturate for that pool. Or in other words, you're guessworking the liquidity depth of the pool. So you never know how much liquidity you're actually going to get per the incentives that you are depositing. So while looking at these limitations, we decided, okay, let's build something that is symbiotic with the underlying AMMs, meaning that we're still allocating liquidity to the same underlying AMMs, but we give more flexibility for real-time liquidity adjustments. And in addition to that, we give a deterministic outcome in terms how much liquidity you get per deposits that you incentivize. Okay, so what's our new system? Our new system is comprised by these two different parts. So Autopilot, the LP-centric product, it's a pool allocator that will optimally allocate liquidity across our option set. And this option set, it's just a liquidity management pool. So we use the ERC4626, which makes it super composable, and you can use the receipt token across DeFi. And at the same time, you can configure this liquidity management pool with both assets and DEXs. So imagine at launch, we're going to launch AutoETH, which is going to be configured with assets like, for instance, STETH, RETH, SFraxETH, etc. And you can configure it with additional DEXs, such as Balancer, Curve, Maverick, and others. So if this is the LP component, where the value proposition is pretty trivial to understand, because when you want to provide liquidity, generally as an LP, you are not just focused on a single pool, but rather a set of pools. The other part is complementary, meaning that the liquidity marketplace is a liquidity management tool that allows DAOs to essentially tap into any liquidity that is available on a given option set. So if a DAO wants to rent liquidity to a pool that exists on AutoETH, they just need to deposit the respective incentives, and the rate that they pay, it's the liquidity rate. And this is the market rate that is discovered by Autopilot in an LMP. And this doesn't exist in DeFi yet. We have a price for liquidity. It's true that you cannot rent liquidity unless it is present on an option set, but it's a game changer, in my opinion. So Autopilot, what's the design goal? The design goal for Autopilot is to optimize LP deployments beyond what individual LPs are able to achieve, especially over longer time periods, meaning you would deploy liquidity to an option set and you outperform any of the underlying pools. And when I say a liquidity management pool, the only thing that you conceptually need to understand is that it's just a pool that has a lot of pools inside. So it's kind of a meta structure, nothing else. So what inputs does Autopilot take into account so that LPs don't need to account for? You have the APRs and all of its different components. It's important to emphasize these different components because APRs cannot be taken at face value. A 10% on Curve is different from a 10% on Balancer. You have a different price risk associated with the reward token. You have different trading fees. So ultimately, you have different stabilities for the APR over long time periods. In addition to that, Autopilot also accounts for rebalance costs. So whenever you are rebalancing liquidity to a new destination, you need to account for slippage, gas, trading fees. Okay, in addition to that, given that at product launch, we're really going to be focused on the value proposition for ETH holders, we developed specific infrastructure that allows us to check the actual ETH backing that LSTs have on the beacon chain. So what we do is checking the backing, comparing it to the exchange rate, and then comparing to essentially assess if there is a discount or a premium that we can take advantage of in order to further optimize performance. Then we also account for liquidity constraints, meaning that any pool that is present on the option set, if you allocate liquidity to it, you need to ensure that you can always exit to the underlying asset, which at first it will be ETH, but as I mentioned, we're going to expand to stable coins, and then other volatile assets that are going to be categorized by volatility. And then finally, the likelihood of APR stability. If you do not account for APR stability, you're going to lead to NAV decay. You're going to cause churn. And this is only going to further deteriorate your performance. So it's very important to account for this future APR stability. Okay, so what's the core structure? So on a high level, you can think about the architecture for Autopilot according to these three pillars. The first one, it's the composite return metric. This is really the autopilot input. It's what the autopilot will see on any of the destinations that are included on the option set. Furthermore, we have a rebalance constraint. So this is the gatekeeper for rebalances. It's the condition that triggers a rebalance to occur and basically says yay or nay to it. And then finally, we have the adaptive rebalance constraint. So this is the self-learning component of the system that is basically going to adjust the way that the rebalance constraint works depending on the volatility that we are experiencing within the market. Okay, composite return metric. If you recall, I said that you can't take APRs at face value. So what we do is we decompose and dissect the APR into all of its different components. You can see here the base APR, fee APR, incentives APR, etc. What this allows us to do is essentially to overweight or underweight different components. So for instance, if your alpha to improve performance is the incentives APR, you might want to overweight this parameter versus, for instance, the fee APR, which can be noise. Now, these are just examples, and what I want to highlight is that this simple expression shows us how powerful it is to then further optimize the system by changing these weights over time whenever we think about the different APR components. And this allows us a lot of granularity and flexibility whenever we deploy new liquidity management tools. So this is what it means to have fluid liquidity. And this is how we parameterize it. Okay, rebalance constraint. This is simplified, but you can imagine a simple condition that essentially states that the expected incremental return that you have on a given liquidity move to a new pool, normalized over a one-day period, times the rebalance cost offset period, which is the time that you have to recoup the costs associated with the move, needs to exceed the rebalance costs. So in other words, if you are going to chase this incremental APR, you need to be able to recoup those costs within a given time frame. Now, the two important questions to address here are the following. How do you define R, which is the rebalance cost offset period? And how do you actually conduct the liquidity rebalance? So this R value is adaptive. This is the machine learning part of the system. And it is adaptive in the sense that depending on the market conditions, the system is either going to loosen or tighten this R parameter. So as you can see here on the left-hand side with the same set of pools that I exposed earlier, there is a clear winner. And as such, the system is going to loosen the R parameter in order to chase this incremental APR. However, as things become murky and the volatility associated with the APRs also increases, what the system is going to do is tighten the R value, which means that the expected incremental return that you get on your APR needs to be higher and it needs to be offset on a shorter time frame, so on less time to recoup that cost. And this is how you adapt the self-learning component of the system to be aware of its environment. Okay, now the liquidity rebalances. How does a liquidity rebalance actually take place within the system? So everyone is probably familiar now with intent-based architectures, and what we do is we rely on a decentralized solver, and solvers can compete off-chain and propose solutions to the autopilot contract. And then there is an on-chain component that is going to verify if these solutions represent an improvement. If they do represent an improvement and they do not violate any of the imposed constraints, then that on-chain component is going to execute the solution. So this is the most elegant trade-off that we found between off-chain and on-chain. And on a personal note, I do believe that as more market makers enter the space, we're going to see more and more off-chain liquidity, and the on-chain component of, for example, Ethereum, it becomes a settlement layer. So this is just a diagram, a visual illustration of the overall system. So the left-hand side, it shows you autopilot. And the life cycle of an autopilot user, it starts with the user depositing funds. So as I mentioned at the start, the user can deposit ETH into the system. This ETH is going to be deposited into one of the various LMPs. So for instance, you can deposit into AutoETH, and then that ETH or that ETH LST is just going to be swapped into whatever optimal allocation the autopilot rebalances it to. And then the autopilot will continuously monitor this, and it will ensure that as APRs change, you are always capturing that delta that will allow you to outperform any of the individual pools included in the option set. As you look to the middle of this diagram, you see the word predictable liquidity. What does this mean? Well, with autopilot, there is no voting on liquidity allocations. If that was the case, you'd be compromising optimal liquidity for LPs, and you'd rather create value accrual for token holders. That's not what we're looking at. We want to treat LPs as first-class citizens. As such, the autopilot will only react to market rates. And that's why the liquidity marketplace then has a liquidity rate, a price for liquidity, where if a DAO decides to rent liquidity on any of the pools that represent the option set, they can do so, and they have a price to do so. So you deposit incentives, and you know exactly how much you're going to get back. So the first iteration of a liquidity marketplace, it's actually a pretty simple rewarder system. And we are doing this because it achieves basically like 80% of our goals with less engineering effort that is fully focused on autopilot now. However, there is a more complex implementation for the liquidity marketplace where you have an actual liquidity order book a la UniV3 bins, where DAOs can place bids for liquidity. This is more complex, and it only makes sense to create this solution if we see that there is a lot of traction and demand on the original liquidity marketplace. What I want to emphasize on the full system is that we don't need demand on the liquidity marketplace to ensure that autopilot works. And what we want with autopilot is to change how LPing works in DeFi and introduce dynamic LPing. So LPs just decide what's the option set that I want. I select DEX ABC, I select asset XYZ, and now my liquidity is automatically rebalanced in a passive manner and in an optimal manner. Okay, this part is our great design made by Victor. His brother is here today. So what you're going to see, it's his work. Okay, so this is just an example of one of the many LMPs. Once you enter an LMP, you can see a lot of its stats like historical performance, etc. But the part that I want people to focus on, it's this one. So this is really what an LMP looks like visually. So as you can see in the liquidity flow, when you deposit into an LMP, and this will be highlighted as soon as it's live, you will be able to immediately see visually to which assets your liquidity is allocated to. In addition to that, all the DEXs that are currently being deployed to. So you get a visual representation of the live liquidity rebalances and the current allocations. And I think that if there is an image to depict this, Victor was really able to get the perfect one. And as soon as it's live, you'll see with probably green highlights what's the liquidity path flow and how it changes over time. So for the ones that prefer pie charts, you also have the more boomer version. And now I want to just address where we are right now and what's next for us. So as of now, we are on the stats contract launch, which is going to be launched on mainnet in the upcoming days. This is what's going to allow us to essentially retrieve historical data and pricing that is not available on testnet. Then we have the finalization component. So we already did 2 preliminary audits. We're going to do a third one with Sartora for formal verification. And then we also have a lot of fuzz testing ahead of us. And the final one, it's really the mainnet deployment. So for the mainnet deployment, we have 2 different phases. There is the alpha launch. During the alpha launch, Tokemak is going to be the sole depositor in the system. So we're going to allocate a large amount of ETH that belongs to the protocol, and we're going to be the first users of our own product to essentially guarantee the system's integrity before we open this up to the public. Then the second phase, it's going to be the open launch. And during the open launch phase, I skipped the full system final audit, so another audit to really make sure that everything is secure. We're taking security far too seriously, but it's never far too seriously. You need to be paranoid about these things. And the final component, as I was saying, which is the public launch, it's when we open up the system to third-party LPs. And in order to make sure that we're able to really bootstrap the entire system once it's open, we're going to have a large bootstrapping campaign in order to attain the amount of TVL that we want, to also kickstart the reward generation to the token holders. And we're also going to introduce later on an update to tokenomics. And as I showed, there will be several LMPs, and token holders will be able to vote on emissions to LMPs. And in order to align incentives and rewards generated by the respective LMP, once you vote to a given LMP as a user, you only receive yield-bearing shares of the LMP that you vote for. So this ensures that you're not concentrating the overall system revenue into the same locked token holders, but you are dissecting it. Okay, so final remarks. I think that this covered on a good high-level scenario what we're doing. And what I want to say is that our mission statement is to introduce dynamic LPing to DeFi and to really change how LPing works. I faced this as a user, and that's where the inspiration for the whole product comes from. And as a user, I wanted to avoid all the work that I was having manually because I want to earn a premium for my ETH above the ETH staking rate. But it was far too tiresome to essentially optimize across multiple DEXs. So this is really what you achieve with liquidity management pools. Autopilot takes care about the liquidity deployment. It does so optimally, and while doing so, you're able to outperform any of the constituents and abstract the underlying AMM models and the switching costs associated with it. So yeah, new way to LP in DeFi. Thank you.